All right, page 9. A particle is traveling along the y-axis. Its velocity is shown below in the graph. At time 0, the position is 4 feet above the origin. So y of 0 is equal to positive 4. Find the change in position from 0 to 12. So let's see. This is 9, 10, 11, 12. Just making sure. Might as well mark off what these are. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Change in position. So we have a trapezoid and a triangle. So the change in position represents the integral from 0 to 12 of v of t dt. I think it's good to get in the habit of writing this so you know how the directions connect to the calculus. All right, so this would be the first area is negative 1/2 times the height of the trapezoid, which is 2, times the sum of the bases. So this base has a length of 3, and this one has a length of 6. We're going to add to that the area of this triangle, which is 1/2. Its base goes from 6 to 12, so that's 6 units, has a height of 2. So the change in position, so this is negative 1 times 9, negative 9 plus 6. So the change in position is negative 3 feet. All right. Part B. At what position will the particle be at 12 seconds? So change in position is negative 3 feet. At what position is saying, okay, you know that it starts at y of 0. You can add to that the change in position from 0 to 12. Again, it's good just to set this up, even though you can just do the math and a couple of numbers. It's good to be able to write out the calculus so you know how it connects to the directions. So y of 0 is 4. We just figured out that this was minus 3. So y of 12, its position at 12, is positive 1 foot, or 1 foot above the origin. Find the total distance traveled from 0 to 12. So total distance is saying what's the absolute value of 0 to 12 of the absolute value of vt dt. And remember, that just would take this area and flip it so it's positive now. So that just means that instead of getting negative 9 right here, we should get positive 9 plus 6. So that's a distance traveled of 15 feet. Okay. At what time will the particle be at its highest point? All right, so we can find out. Do we have to do that in the next one? No, we don't have to find the highest point, just wants the times. So you could do your candidates here, but actually I will. The candidates are the endpoints. The candidates are the endpoints, 0 and 12, or is there highest point? So is there a relative max? That's anywhere where V changes, relative max, positive to negative, and that doesn't ever happen, right? So we go negative to positive, but not the other way. So there are no relative maximum points. So V of 0 is 4. I'm sorry, x of 0 is 4. And x of 12 we figured out was at 1. So yeah, so the highest point will be at time equals 0. What if I didn't have numbers to figure out? Well, I could say, okay, so if I have these areas here, this area was negative 9, this area was 6. So the particle is decreasing first. It starts at 0, it decreases, and then it increases, but it doesn't increase as much as it decreased. So it's never going to get back to where it started. So that's got to be the highest point. So t equals 0. I can either use my extreme value theorem work, or I can say because the net area is negative from 0 to 3, or 0 to 12, excuse me. And there's no relative max. At what time will the particle be at its lowest point? So the candidates here are not just the endpoints. The candidates are the endpoints. The endpoints 0 and 12, but also the relative min. There is a relative min at 6. So at 0, we're at 4. At 12, we're at 1. At 6, we're at 4 minus 9, so negative 5. So if we had to find what the lowest point was, it would be that. But that's at t equals 6, where x of t has a relative minimum. I would just use my extreme value theorem work over here to justify, but you can explain it that way too. What is the acceleration at 10 seconds? So a of 10 is equal to v prime of 10. And remember, that just means what's the slope on v of t at 10. So let's take a look here. At 10, we're on this portion of the graph. The slope of this whole section, it's a rise of negative 2 over a run of 3. So negative 2/3. And then I want to label this negative 2/3. This is a value for acceleration. So the velocity is measured in feet per second. Then we're going feet per second per second. So feet per second squared. All right. Let me just box these in. So that takes care of page 9.